So this is Expert Fonda and you're watching on YouTube. So welcome back. So in this video we are going to break down a super popular interview problem, that is a Leetcode 238, and the problem is product of array except self, right? So we'll go through the step by step and we'll solve it in O of n times without using the division or anything else, right? As per the questions we'll go and we'll understand the situation of the problem. But I want to explain you that I have already created a couple of videos in this playlist, and it is a 6-month interview preparation for the FAANG, and I hope you will like all these videos that I'm going to post. So this is a step-by-step problem solving. I have already created a couple of videos, almost 10 videos I have created, and I'm going with the basics of that, like medium level questions, and then I will go with the hard level questions. So this is to just get started till now. So keep watching this video, and if you like this video and series, please keep liking the video so that YouTube algorithm will promote this video to number of students, right? So let's skip ahead. So the question is saying that we have product of array except the self, right? So let's read the question. So we have given an integer array nums, and we have to return an array answer such that answer at I is equal to the product of all the elements except the nums of I. So the product of any prefix or suffix is guaranteed to fit in 32-bit integer, and you must write algorithm of O of n times without using the division operator, right? So we will solve in O of n time complexity without using division, right? And that will do. Okay, so if you observe this example and you will see this output, so you just pause this video and go through the problem explanation again, and think what is the intuition of this problem. Okay, so you are given an integer array, that is nums, right? And you need to return an array answer, right? A new array you can say, where answer at I is equal to the product of all the numbers except the nums at I, right? So now imagine you are standing at an index in an array, and at index I you want to know the product of all the elements before I and all the elements after I, right? You don't want the current position. Okay, so you are at index I and you want to know the product of all the elements before I and all the elements after I, right? So what will be the product at answer? So let's suppose we have this example, right? So you are standing in the on the index here, right? So in the array its index is 0, 1 and 2. So at index 2 you are standing and you want to know the product of all the elements before this index is 1 into 2, and here after that 4 into 5, right? That is the product of all the elements, right, before and after. So the answer at I is the product of this before one and the product of this one. You have to do multiply again, and that will come at index here, right? Means there will be two passes. So there will be two passes, one left to right to calculate the prefix product and one right to left. Okay, and so we'll calculate the each index each answer at I. Okay, so at index I we have to compute the product of element except nums at I, right? And so to calculate that value we have to do product of all the elements at I elements to the left of I and product of all the elements to the right of I, right? So what I'm trying to say means like this: 1 into 2 into 4 into 5. Okay, so for each index I we need to the product of all the elements before I, that is called left product, and the right product. So if you multiply the left product and the right product, you will receive this, right? So there is two passes that we will do. So the intuition in this step is saying that for each index I, we need the left product and the right product, and so we'll do finally what? 2 into 20 is 40, and you can see the given array is 1 2 3 4 5, right? And if you observe at index this, it is coming 40 that you have seen. Similarly, if you repeat this, you will get the output like this. Okay, so when we do so the first step is to do what? The intuition to understand the problem statement, what need to do. And the second, we will compute the left product and the right product. So for the left product, we will go to left to right, and we will build a left array, right? And this will store the product of all the elements before I. And to do that, what you have to do, you have to go to the for loop of 1 to n, that given number, the given index, and you will calculate answer at I minus 1 into nums at I minus 1. Okay, and whatever will come in the multiply, you will store at answer at I. Okay, so at index left at 0 will become 1, means nothing to left, means we are going to store the product of all element before I, right? So let's suppose we'll go like this. So left at 0 is 1, left at 1 is 1, means this and this. Okay, now if you will do left at 2, so you will multiply what? 1 into 2. So before this, so nothing was left at 0, so we'll apply 1, right? But left at 1, at here we have 1 here, so we will multiply 1 into 1, so you will get 1. But at 2, what we have? 1 into 1 into, if you multiply this one, then it will come 2, right? So like that we have to continue, and we'll get 1 into 2 into 3, and you will get 6, like this you will get. Okay, and finally you will get this value. Means we need to compute the left product. And what will be the left product? So you will have the left product like this: 1 1 2 6 24. So this is called left product of the given value. Okay, so you understand, right? What is the left product, what is the right product, right? So the input array was 1 2 3 4 5, right? And for that we have calculated this left product, right? So we start by creating a left array. So left at I, so any of this value will contain the product of all the elements to the left of I index, right? And so we have taken left at 0 is 1, because there is nothing left to the left of 0, right? Nothing was there. This is a boundary condition, so you have to take it as 1. Otherwise, if you take 0, it will multiply every product and it will become 0. So to escape that, what you have to do? You have to do assign 1. So at 1, it was already 1, so you will multiply, you will get the 1. But at 2, you have 1 into 2, you will get 1 into 2. 1 into 2 into 3, you will get 6. 1 into 2 into 3 into 4, you will 24. Right, 24. And so you will have the left product. I don't need to explain much, but just I am explaining here. So right product, similarly you will find it, and so you have to go by start by 1, and you will initialize answer at left. So if you observe that you are going back to this, so just pause this video and go through. So what you will observe, so at 20, at the last, what we have observed, it was 1, so the array was, left product was 1 2 1 1 2 24, right? So the element at left at 4, this, and you will multiply with the right, right? So what we have at right, we have taken as a 1, and answer we have taken as a left. So if we will do like this, right? So left at 4, left at 3 2 1, we will do multiply and right. So if you multiply all these elements, what you will get? You will get this value, final result, and this will be your answer, right? So if you observe this, right, so in the code part, if you will do if you want to compute the left product, right, so 2 pass we have to do. In the first pass, what we will do, answer at 0 you will apply as 1, so we will not have the left product as all zeros, right? So to do that, what we will do, we will make answer at 0 is 1, and then we'll go for the I equal to 1 to n, all the elements will go, and we'll multiply answer at I minus 1, means this will be 1. 1 into nums at I minus 1. So I is 0, y is 1, 1 minus 1 is 0. So answer at 0 is 1, right? So we'll multiply 1 into 1 and you will get 1. That is, you are getting 1 and 1. Similarly, you will go for the next value, I equal to 2, you will get 2, I to 3, you will multiply. So you will keep doing that, you will get this value. Similarly, if you will go to multiply the right product, what we need to do, first go to right to left, right, and maintain a right running product and multiply it by that, and you will get into the answer at I. So answer at I initialize at 1 and answer is equal to left, right? So at I 4 3 2 1, right? Because as you see, we are going the right product we are taking as a 1, right? And then I will go n minus 1 to till the 0 value, right? Last index to the 0 index. And if you multiply answer at I into the right product, right, and once it is multiplied, you will assign to the answer at I. And so the right product is equal to what? The right product into nums at I is the right product. So if you observe that, so answer is nothing but your left, right? You see answer is nothing but the left you have applied. So all these values are 24 6 2 1 are the left product, right? So we have got from the left product, right? And what is right? So we have taken right as a 1, first one. After that, you are updating the right here, right? Nums at I, you are multiplying that, right? So this is come 5 20 60 and 124. Once you will multiply all these, right, you will get this value, okay? And so the final answer is coming like this, okay? So this is the trick to generate the value, right? So let's do some hands dirty with a code and you will understand how to implement that, right? So what we have to do, we have to do the first step, we have to do left product, and the second we will do the right product, okay? Two steps at least we have to do. The first step, we will fill all the left product with the left product, and then we'll multiply with the right product, right? So to do that, what we need to do, let me zoom a little bit, okay? Okay, so first of all, what we need to do, first of all, we'll do two steps, means two passes we have to do. The first pass will calculate the left product and the second part the right product, right? So let's calculate first the n, how we are going to take. So nums dot length, if we will do, you will get what? The n, number of element you will get, right? And then we have to define int the result, right? We'll find the result. Let's suppose I'll do the result is res. So result array will do, and we'll store the all the values in this and we'll return it. So we'll take the same size. After that, what we should do, right, we should do the first step. The first step will do res at 0 is nothing but 1, okay? And then we'll go for the first pass. So first pass, what we have to do, we'll index at I equal to we'll take from the 1, and I is less than equal to, or sorry, less than, will go n directly, n minus 1 no need to do, and I plus plus, okay? So as you can see, the first pass is ready to do that, and in the first pass, what we will do, we'll calculate the res at I. So index at I, if we'll do, so we have to get what? Res at I minus 1, right? And we'll multiply this with nums at I minus 1, right? So you will get the product and you are assigning the value. Now in a step 2, what we have to do, we have to initialize first the right product. Let's suppose it will say right at right is 1, will initialize, and then we'll go for the loop. So loop will be int I will be from n minus 1, right? Means last index, and then I should be greater than equal to 0 and I minus. So the left pass and the right pass. Now this is the right pass we are doing. So right pass we ready to do. So what we have to do here, first of all, so res at I, we will multiply with the given number, right? Given you can say right. So right we have initialized from what? 1. So we'll multiply this, right? Whatever the data will be there, it will store into res at I. Then update the right value we have to update equal to nums at I, right, like this. And then once it is done, we'll return res, right? Return res like this. Okay. Okay. So what we have observed, let me zoom out. As you can see, right, what we have observed, we have 2 steps we need to do. The first step is the first pass where we will calculate the left product, right? And to calculate the left product, what we have to do, assign res as at 1, and then you will multiply the res at minus 1, right? Means from the res I minus 1 will multiply with the nums at I minus 1. You will get the all the left product you will get here. Now to multiply with the right product, right? How will you find the right product? So just take right as a 1, right? And multiply with the given res, right? And you will store, after the multiply, you will store at that index. After that, what we need to do, you have to update the value nums at I, you have to multiply, and you have to update the right? And then finally we'll return the res. Okay. And the time complexity and space complexity. Okay, so if you talk about the time complexity and space complexity, right? So we have make 2 linear passes through the array. The first pass was the left product and the second pass was the right product, right? So the 2 linear passes we have done. The left for the first pass we have taken the left product that have taken O of n times. To we have started from the index 1 to n, right? And we have gone through all the passes. So I've built an array res, and then we have gone through the storing the value of product of all the elements to the left of it, right? And so after that we have gone for the second pass where we have calculated the right product using the reverse order of the array, and then we have calculated the right product, right? And once both product as ready, right, then what we have done, we have initialized we have multiplied those, and we have calculated the result. But both passes taking O of n times because we are just moving from the all the elements of the array. So total time, if you talk about that, is time complexity is going to be O of n times, right? Because O of n plus O of n is O of n time, right? So so the first pass we have taken we have built the array and we have stored all the product of the elements, right? So it's taken O of n, and for the right product we have taken O of n times. So total it will become O of n plus O of n is O of n times, right? So if you talk about the space complexity, so including the output array, right, we do not have any extra array apart from the output result array, and according to the problem the output array does not count towards the space complexity. We only use a few scalar variable, int, you can say the loop counters and those things, right? So that's all for today, guys. Let me know if you have any doubt. So if you think that this video is helpful for you, so please hit subscribe this channel and comment if you have any doubts. Okay, so your likes is very important for this video, and so that more viewers will come for this video. Okay, so if you gonna ask in the interview that we achieve O of n times with O of 1 auxiliary space including the output array. So by using the result of the left product and the single variable for the right product, right? So interviewer will understand what you're trying to say that. Okay, never go with the brute force approach because it will take a nested loop and the time complexity become O of n square, and space complexity O of 1, but the time complexity will become O of n square, right? So better do not go for the brute force approach, because in the interviewer will say, see, it is too slow for the larger array, and that is not acceptable in the interview. Okay, so you will optimize it. So better you optimize it. Okay, so before implementing the code, you just say that the brute force approach, I can do that. That will be the nested loop, but it will take of n square. But the question is saying that we have to go with the O of n times. If you remember, okay, so if you remember, the question is saying you must write algorithm of n times without using an division operator, right? And so we cannot go for the you can say brute force approach, nested loops, because it will be too slow for the larger array, and it is not accepted in the interview. So you just tell that there is a naive approach that we can do by the division, right? We can do division and we can do by O of n or O of 1 times, but that is not acceptable also, because we can the code will get accepted, but it requires a special handling for zeros, count of zeros, you can say, that is a edge cases, right? But the you can say no, if you will go with no division, that will be our optimal solution, because it will take O of n times and a space will get counted for O of 1 times if we discard the output array, right? So we will use prefix and suffix product in a place, and space will be constant if the output array is excluded. That's all for today, guys. Let me know if you have any doubt in the video, and I hope you will like this video, and your comment is very important for me and for this video. Thank you, guys. Thank you for watching this video.